same thing, just a different equation. So remember, we're being asked to find an inverse, and they want to know if it is a function or not. The function thing is kind of important because finding inverses, are important. And sometimes you'll have like a function, and when you do the inverse, it doesn't have an inverse, or it's not a function, it's just an equation. And then so that causes some other problems too, with regards to the domain and range and stuff like that. So one way you could kind of look ahead of time by just graphing it. So for example, I have this f of x thing, because you don't want to waste a lot of time, right? So if I, for example, if I delete this and I just graph the function 2 times the square root of x minus 3, right? And then I put my y equals x, okay? And I make that a dotted line. Okay. What would my inverse function look like? Well, it'd look like this, but it would be a mirror image up here, right? So if the mirror image up here would kind of look like this, it'd probably look like this, right? If I drew a vertical line through that, would it be a function? The answer is yes. In other words, if I had a line like this, right, because this is my function, the inverse would probably be the mirror image across this line, so it would come down and curve like this. If I drew a vertical line through that, it would only cross one time. So I'm pretty sure it's going to be a function. So what we're going to do is we're going to come back here and go through the process. So what's the first step in finding the inverse? What do? We're given the function f of x is equal to 2 times x, or the 2 times the square root of x minus 3. Anybody know off the top of their head? Or even if it's not off the top of your head, look in your notes. What do? We're going to plug in a y wherever there's an f of x. So I change this to y equals 2 times x minus 3. Or I'm sorry, square root of x minus 3. Step 2, we're going to solve for x. We're going to make it look like x equals some stuff. We're going to put x on one side of the equal sign and all the other stuff on the other. You follow opposite, right? So the square root is like parentheses, kind of. It's a grouping. And so I'm going to move the 2 first by dividing. So now I've got y divided by 2 is equal to the square root of x minus 3. To undo the square root, I square. Whatever I do on one side, I have to do to the other. On this side, I get x minus 3 because when you square a square root, you get the base. Now over here, if I push this 2 through the parentheses, I'm going to have y squared over 2 squared. Next, I add 3 to both sides. So I'm just going to leave this like y squared over, what's 2 squared, by the way? 4. And then I'm going to say plus 3 equals x. All right. We did this. We did this. Next, I'm going to replace or swap the x and y's. Wherever there's a y, I plug in an x. Wherever there's an x, I plug in a y. But I'm also going to flip-flop it. So I'm going to say y equals x squared all over 4 plus 3. Last step. Plug in the f inverse notation wherever there is a y. So this becomes f inverse of x is equal to x squared all over 4 plus, oops, plus 3. So then I'm just going to plug that into my graph over here and see what's up with that. So I'm going to say x squared divided by, frustrating, divided by 4 plus 3. Now the only thing that we have to think about, notice that when I graph this, this is a quadratic, okay? So I have to put in some boundaries. Over here, remember the range and the domain flip-flop. So what's the domain here? Or better yet, what's the range here? Because I got to define the domain over here. So what's the range here? Well, it goes from 0 to positive infinity. So that means that my domain has to be defined. I got to remember how to do that. I think it's like x is greater than or equal to 0. Yeah. Okay. And the reason for that is because my range of f is 0. And so anyways, let's just take the screenshot of this. And we'll write some words down in our notes, okay? Save it. So let's start with f of x. So this is f of x, which is 2 times the square root of x minus 3, right? And so I should point out that the range, which are all the y values for this, is y is greater than or equal to 0. Now, why is that important? Because it helps us to define the domain of f inverse. So this is f inverse of x, which is equal to x squared over 4 plus 3. Now that has a domain of x is greater than or equal to 0. Okay? And so we should probably write that down here on the bottom somewhere. The domain of f inverse of x is the range of f of x. Let's make it nice and clean. Right, because remember we said the domain and the range flip-flop. So that's an important thing to keep in mind. But even if you don't, like, so let's say on the test I give you a graph and I say graph the domain, or not graph the domain, graph the f inverse of f. Well, you're going to have a mirror image. So if I were to graph this equation in Desmos and it went all the way over here like it does, is that the mirror image of this? No, you only graph on the paper the mirror image. Does that make sense? Okay. Are there any questions? All right. That's it.